Hello and welcome to our lesson on arithmetic sequences and series. Before we get started with what it means to be an arithmetic sequence, let's just talk about what it means to be a sequence. So in mathematics, we call sequences lists of numbers, or lists of numbers are called sequences. So a sequence is just a list of numbers, and it may or may not follow a pattern, but when there is a pattern such that you're adding a fixed number to get from one number in the list in the sequence to the next, then we call that an arithmetic sequence. So an arithmetic, and just to be careful with this word, arithmetic is the same spelling as the word arithmetic, but there are two different meanings. When I say arithmetic, I'm pronouncing it that way because it's used as an adjective. Arithmetic would be a noun, like something that you study, right? Reading, writing, and arithmetic. So it's arithmetic as an adjective. But an arithmetic sequence is when you have a list of numbers that's formed by adding a fixed number to get from one term or one number to the next. And that fixed amount that gets added to form your arithmetic sequence is called the common difference, because it's the difference from one number to the next. And we're going to use the letter D to designate that common difference. Okay, so for example, let's say we're looking at this list here, 2 followed by 6, then 10, then 14, and so on. We should be able to complete the list, and find the pattern to do so. So I can see here that I'm adding 4, and then I'm adding 4 again. So if I just, I skipped one, but 2 plus the 4 makes 6, 6 plus the 4 makes 10, 10 plus 4 is going to make 14. So 14 plus 4 would make the next number on this list 18, and 18 plus 4 would make the next number on this list 22. So we would say that this is an arithmetic sequence because there's a common difference between all of the terms, and we would say that that common difference is 4 because that's what we're adding to get from one term to the next. Okay? Same thing here. I can see this time we're subtracting, just means we have a common difference that is negative. So I'm subtracting 5 here, subtracting 5 again, subtracting 5 again. So if I subtract 5 from a negative 12, I get negative 17 for the next term. Minus 5 would be negative 22 for the next term, and that would continue. Then if I had to work backward to find the first term that's on this list, instead of subtracting 5, I would add 5. And so let's add 5 here to make this first number an 8. So again, this is a sequence where we are adding a fixed number. We're adding a negative 5 each time. So it's an arithmetic sequence with a common difference of negative 5. Okay? Now, we're going to look at something called an explicit formula for an arithmetic sequence. And the purpose of this explicit formula would be to find any term that's on the list. So if I give you a list like example 1 here, and I said to tell me the 4th term, that's really not a big deal. Or the 5th term, if I wanted to just add 4 to the 4th term, I could get to that 5th term. However, if I asked you to find like the 100th term on that list, adding 4 so many times to get to that 100th number would be kind of tedious. And because there's a pattern, we can write a formula, and that formula could be used as a much faster way to find that 100th term. So that's what the explicit formula is. It's a formula that can be used to calculate a specific term from the sequence. So if we want to just write the explicit formula, which you could be asked to do, just write a formula to represent a sequence, then this is our generic version of the formula. If we want it to represent a specific situation, then what we're going to do is plug in two things. We're going to plug in this, which we call a sub 1, and this, which we call, or obviously that's d, but we call that the common difference. So we need to know two things in order to write our explicit formula. We need to know a sub 1, and we need to know d. And a sub 1 just represents the first term on the list. So let's make a little note there. That is the first term on the list, which kind of makes sense, a sub 1. If I said a sub 2, then that would be the second term. A sub 3 would be the third term. A sub n, which is what we see here, is representing any term. And if we plug those two items in, again, we will be able to write our explicit formula. Now, the purpose of the explicit formula is to be able to find numbers that are on the list. So if you want to use this formula in order to actually find a term that's on the list, then you're going to plug in a third piece, which would be n, or the term number. So if I said to find, let's say, the 50th term, then you would put a 50 in here for n. Or the 100th term, you'd put 100 in there for n. Okay, so let's practice both here. Number 3 just says to write the explicit formula. So we're not doing anything with it, we're just writing it. So I need to know a sub 1, which I have. A sub 1, the first number on my list, is 3. And I need to know the common difference. That is, what are we adding to get from one term to the next? So I can see 3 plus 5 is going to make 8, plus 5 is going to make 13, and I could just keep adding 5 to get down that list. So the common difference is going to be 5. And I can see that here. So common difference. Once I have those two terms, again, I'm just plugging them in. So the explicit formula says a sub n, which is going to represent any term in that list, is going to be equal to a sub 1, which we said is 3, plus our common difference, which we said is 5, multiplied by n minus 1. And that would be a perfectly acceptable way to leave that formula. So if you wanted to give that as the answer, that would be, again, totally acceptable. However, this is something that we could simplify. So we could also simplify this out. We could say that a sub n is equal to 3 plus, if we were to distribute, we'd get a 5n and a minus 5. So 5n minus 5, and these are like terms, so I could combine those and call this 5n minus 2. So this would be an acceptable version of the formula as well. I am totally okay with either one. Just, if you're working in your Canvas assignment, either one of those would be an acceptable answer. Or if you saw multiple choice, you could select both of them as correct answers. Okay? Now again, that's just writing the formula. The purpose of this formula is to find missing terms in the list. So for the next example, it says to find the 50th term. That means that n is 50. So we have that piece to also plug in now. We're also going to be plugging in our first term like we did before, and that's going to be 12. We're also going to plug in our common difference like we did before. And in this case, I can see I'm subtracting 4 to get from one number to the next. So all three of those items get plugged in. So when we plug those in, it's no longer a sub n. It's not just any term on the list. It's the 50th term. So we're going to say a sub 50 is our first term of 12 plus our common difference, which is a negative 4, multiplied by n minus 1. Well, n again is going to be 50, so it's going to be 50 minus 1 there. And then this is something that we can evaluate to figure out exactly what that 50th term is. And just so I don't do anything silly, I'm going to plug that into the calculator. So 12 minus 4 multiplied by 50 minus 1 is going to be a negative 184. So to answer this concisely, I'm going to say a sub 50 is a negative 184. That is, the 50th term on this list would be a negative 184. So if I was to just keep subtracting 4 until I got to that 50th term on the list, that's what it would be. All right. This is a you try, so if you're feeling pretty comfortable with this, it would be a good spot for you to pause the video and try it out. And if not, totally fine. This one says to find a sub 100 and gives us a first term, gives us a common difference. So a little less words, but all the information we need. So we're going to plug in. This would be a sub 100, which means we're looking for the 100th term on the list. We'll start with a sub 1, which is 10. We'll add the common difference, which is 6. N minus 1 times, but again, n is 100, so that's 100 minus 1 going in. And then we're going to plug that into the calculator, again, to avoid making mistakes, which I tend to do. I don't know about you. And we put in 100 minus 1, and there it is, 604. So a sub 1 equals 604. That means the 100th term on this list would be a 604. That means we have a list that starts at 10, and if we continue to add 6 100 times, we would end up at 604. All right, so we have the explicit formula again for finding terms. The next formula we're going to look at is not really a useful formula in terms of using it to find a term or something like that. The next formula is really just a mathematical way to state the pattern that we see in our sequence. And we call it writing a recursive rule, or sometimes it's called a recursive formula. So recursive rule, again, it just shows the pattern. What is the pattern for the sequence? So for example here, this pattern is, well, let's add 5, right? We're just adding 5 each time. And so to write this recursive rule, the only thing that's going to change from one arithmetic sequence to another is where the sequence starts. So like this one starts at 18, or this one starts at 5, or this one starts at 4. So we have to make sure we identify where our sequence starts, and then the common difference can vary. So the common difference here is 1, and negative 1. One more. There we go. The common difference here is going to be a negative 7, and again the common difference over here was a positive 5. So what's changing is our first term and our common difference. Those are the only couple of things that we're going to have to worry about when we're writing our recursive rule or using a recursive formula. So to write this rule, we have to state the first term, right? Because again, that's going to vary from situation to situation. And then we have to plug in the common difference d into a formula that says a sub n equals a sub n minus 1 plus d. So what this is saying, let me interpret this again, a sub n represents any term on the list. This is saying that any term on the list can be found by taking a sub n minus 1, which is technically notation for the previous term. So if a sub n, let's say we were looking at a sub 7, n minus 1 then would be 6, and 6 is the term that's right before 7. Or if we had a sub 8, if n was 8 instead, then 8 minus 1 would be a sub 7 here. So a sub n minus 1 would be one term before the term that we had here. So we have any term on the list is going to be the previous term, that's notation for the previous term, plus the common difference, right? The difference. So hopefully that makes sense as a rule. And in fact, we could write this another way. This is the way I prefer to do it. But we could also say, let me just put a version in here. We could say a sub n plus 1, which would be like the next term on a list, is a sub n any term plus that common difference. So if I take any term on the list, add the common difference, I get to the next term. So n minus 1 is the previous term, a sub n plus 1 is going to be the next term. Alright, hopefully that makes sense. So let me show you an example. If I said, what's the recursive formula, or what's the recursive rule for this particular sequence? Well, this sequence starts at 18. Why is my pen so ginormous? So we're going to say a sub 1 equals 18, and then we can say that any number on this list that starts at 18 is going to be the previous number plus the common difference on this one we said was 5, and so we're going to put a plus 5 there. And that's those two pieces, where we start and what we add, are the only two things that will change when we do this process. So again here, this list starts at 5, so we're going to say a sub 1 equals 5, and then any other term on this list can be found by taking the previous term and then subtracting 1. Again, because our common difference here was a negative 1, and so minus 1. And then one last try. Again, if you feel confident here, pause the video and see if you can do this. So this list is starting at 4, and then any term on this list we can take by taking our previous term, a sub n minus 1, and then this time we said we were adding 7. So d is going to be positive 7, and so we're just going to add 7. And that's it. So recursive rule, recursive formula, it doesn't really do much for us in terms of work, but it is a mathematical way to state the pattern that is happening with that sequence. Okay? And so let me just be thorough here. This entire thing represents the answer. So you can't just state that formula piece without saying the first term, because the formula depends on that first term producing that specific list. All right, now what we're going to look at in the back here is what we call an arithmetic series. An arithmetic series is the sum of our arithmetic sequence. So it is the sum of an arithmetic sequence. So instead of just separating those numbers with commas, if we put plus signs in between and added all those terms up, we would have the sum, which we call a series. So we have a formula to evaluate the sum. So S sub n represents the sum for n terms. And it says we can take the number of terms, n, divide by 2, and then multiply by a sum of a sub 1, which we already know is our first term, and then a sub n. Now notice the n here and the n here. If we're looking for the sum of 10 terms, both of those would be subscripted with 10. So a sub n would be the 10th term. Or if you were looking for the sum of 50 terms, then we'd be looking at a sub 50 in the parentheses. So it will always end up being the last term on the list. So we need three things to use this formula. We need to know n, which is the number of terms, a sub 1, which is the first term, and a sub n, which is the, I can't spell, last term that's on the list. Okay, so n was the number of terms, a sub n was the last term, so this is number of terms, and then a sub 1 we already know is the first term. So again, three things: n, which is the number of terms, a sub 1 is the first term, and a sub n, which is the last term. Alright, so let's try this out. We want to find the sum. We have a list that starts at 1, ends at 45, and there are 12 numbers on this list. So we have all three pieces. We have a sub 1 right there. We have a sub 12, the last term on the list there. So we're just going to plug these things in. The sum for these 12 terms would be 12 divided by 2, multiplied by the first term, which was 1, and the last term, which is 45. And again, just so I don't goof anything up, I'm going to go put this in the calculator. So 12 divided by 2 multiplied by the sum of 1 and 45, and that's 276. So again, this would be the sum for 12 terms equal to 276, which is not so bad. Okay, now the next one, again, it says to evaluate the sum, so instead of find the sum, evaluate the sum, but the same sort of problem. Now, in order to evaluate sums, again, we need to know three things. Just for organization, we do this a little differently. We need to know the first term, which we have is negative 50. We got that here, right? A sub 1. We need to know the last term, so a sub n is 400. The issue is we also need to know how many terms are on this list, and I don't have that information here, right? There's this dot, 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 so what's in the middle, how many terms are missing there? I don't necessarily know. So I'm going to have to use a different formula before I can use my sum formula. So my explicit formula, remember, says any term on this list is the first term plus the common difference multiplied by n minus 1. I need to know n. Since that's in my explicit formula, I can use my explicit formula to figure out what that n is supposed to be. So the last number on my list is 400. That's a sub n. And a sub 1, that's given to me as negative 50. My common difference, I can see, I'm adding 15 to get from one number to the next. So I can put a 15 here, and then n is going to stay in as my variable. So now I can solve this equation for n. I'm going to add 50 over. And so now I have 450 equal to 15 times n minus 1. And actually, let me just back up. I can go ahead and distribute that. So that's going to give me a 15n and a minus 15. So 15n and a minus 15. Now I'm going to add the 15 over. Divide last, and then I'm done. So carry this over here. I'm looking at 465 equal to 15n. And now I can divide both sides by 15. And now I know that n, which is the number of terms on my list, is whatever 465. 465 divided by 15 is, and it better be a whole number because we're not going to have a fractional number of terms in our list. And there it is, 31. So n is going to equal 31. So there's 31 numbers on this list. Now I have all the information I need to find the sum. So now I want to find the sum for those 31 numbers. And that's going to be 31 divided by 2 multiplied by my first number, which was 50, added to my last number, which was 400. And again, I'm just going to input this into Desmos so I don't goof it up. So I have 31 over 2 multiplied by a negative 50 added to 400, and then I have 5,425. So if I made this list of all 31 numbers and added them together, that's the sum that I would end up with. Okay? Again, if you're feeling pretty good about this process so far, pause the video and give this next one a try. Otherwise, you're with me. Let's keep going here. So here's another one where we don't have enough information. So this one says find the sum of 30 terms. So I know n is going to be 30. I also know here a sub 1, but I don't know what the last number on my list is. I know it's going to be the 30th number, but I have to calculate it before I have enough information to find my sum. So I'm going to start this one again using my explicit formula because that one can be used to find any term. So here's my explicit formula again. This time I want to figure out what is the last number on the list. What is that 30th number? So a sub 30 starts at a sub 1, which is 3, plus the common difference. I can see I am adding 5 here. And it's going to be n minus 1 times, well, n is 30, so 30 minus 1. So a sub 30 is going to equal, again, let me just go to my calculator, 3 plus 5 multiplied by 30 minus 1 is 148. So now I know that missing number at the end of this list is 148. Now I have enough information to find my sum. So the sum for these 30 terms that would make up this whole list would be 30 divided by 2 multiplied by my first term, which is 3, plus my last term, which is 148. And so the sum for those 30 terms, again, calculator, 30 over 2, and I know it's 15, but I just, I don't want to make any mistakes, so I'm going to just type it all in there. Alright, so 2,265 is the sum for those 30 numbers on that list. Okay, so hopefully not so bad. Now the last piece is really doing the same thing that we just did. It's evaluating a sum, but it's using what we call sigma notation. It's kind of a fancy one, but if you're going to go on to higher levels of math, you'll definitely see some more of this. So you might be asked to evaluate a sum with sigma notation. The symbol, like this, that little sort of E-looking thing, is our sigma, Greek letter sigma, and it means to find the sum. So for instance, when you see this whole notation here, if you are reading this, you're going to sort of read the sigma as find the sum, and it would be from n equals 1 to n equals 25, so from the first through 25th terms of the list that is formed by this explicit formula. So this is the formula. They're telling you 25 numbers on the list. If you were to add all 25 of those up, what would that sum be? Okay, so it looks a little fancy, but they're giving you the explicit formula and telling you if we added up all 25 terms formed by that explicit formula, what would that sum be? Now, we're still trying to find a sum the way we did before. So if we want to find a sum, just like in that last, it's the same formula we just used. It's our sum formula. This is just a different way to read the question. We need to know the first term, we need to know the last term, and then we need to know how many terms there are. So we have to figure out what that first and last term is, because all we know is the rule that produces those terms. That's our explicit formula. So we're going to find a sub 1 and a sub n, find that first and last term using that explicit formula, and then we can use our sum formula. So if I wanted to find the first term on the list, I'm going to plug a 1 into my explicit formula. So if I plug a 1 in there, it's going to be 4 times 1 minus 6. So the first term on this list would be 4 minus 6, which would be a negative 2. And then I would find the last term on the list, which is going to be the 18th term. So a sub 18 would be, again, plugging an 18 in there. So 4 times 18 minus 6. And let me, again, not make any silly mistakes. 4 times 18 and then minus 6 is going to be 66. And now I can find the sum. So I'm looking for the sum of those 18 terms. It's 18 divided by 2 multiplied by my first term added to my last term. And so the sum for these 18 terms would be 18 divided by 2 multiplied by negative 2 plus 66, which is 576. Okay? Now, That wasn't overly difficult to work. However, we do have technology that understands this sigma notation probably better than we do. So I think in the other situations where the words are all laid out here, it makes sense to use the sum formula. But this sigma notation was developed well, for a few reasons, but one reason is because calculators understand this. So if I plugged the sigma notation in my calculator, it knows that I'm asking it to find the sum of numbers that are on the list. So we can also use Desmos to do this evaluating. So or use Desmos. Okay, add that to your steps up there. So this one, that's a you try. If you want to try to find this in Desmos, you are welcome to pause the video and give it a shot, but let me show you. So if you go into functions, and then I think it's, in miscellaneous, there's the sigma down at the bottom of the middle column there. So I'm going to press the sigma, and it's got n in here as a variable. It doesn't really matter as long as you use the same variable throughout. It's not going to matter. So if you want to change that to an x, you can, but I'm going to leave it as n. So we're going to go from the first term to the 30th term, and the explicit formula is 5 minus 2x. Or actually, in this case, I'm using n. So I'm going to go to my keyboard and call that an n. And close that off. And notice it's giving me this error sign. And that's because I want to... I want it to ask sigma, or ask Desmos to find this sum of that explicit formula, but right now it's like it's doing order of operations. It's finding the sum of 5. If 5 was the only number on your list from 1 to 30 times, that sum would be 150. If we want to keep the 5 minus 2x all together, I'm going to have to put it in parentheses. So 5 minus 2. Again, I'm going to use n because it changed it here. So there it is. So I need to make sure to use parentheses when I enter this in Desmos, otherwise it's exactly as shown. And Desmos says that this is going to be equal to, what was it again? Negative 780. So we would say that the sum for these 30 terms is a negative 780. Okay, and if you're just not convinced, let me show you what the one that we just did. So again, put this in here. Back to my keyboard. So functions, miscellaneous. So this last one we went from the first through the, my finger is too fat here, 18th term. And again, if I just put in 4n, and then if I put in the minus 6, it does not give me the same answer I had in my paper. That's because it wants parentheses. My goodness. There. And now we got our same answer. So make sure if you're going to use Desmos that you use parentheses around your explicit formula, but you're welcome to use that. And so actually I like the sigma notation. When I'm doing problems like these, I will often use the sigma notation because, like on number 8 for instance, we had to find our explicit formula. So if you want to find your explicit formula and then use sigma notation and Desmos to calculate the sum, you absolutely could. But if it's a little much for you and you don't want to do that, you absolutely do not have to. You've got some options. Okay, so hopefully what I've shown you is enough for you to work on that practice. But as always, if you need some extra help, then just reach out. All right, till next time, take care.